I work for the state of Tennessee, STS GIS Services. Drove from Reedyville this morning. It was a nice drive. I was hoping to see the meteor shower, but it was a little bit too foggy out. It's disappointing. So typically I handle three types of data, and that's cadastral data, so parcels, imagery, and now with the onset of the 3DEM program and our partnership with USGS, LIDAR data. So what I'd like to do is just kind of go through our public-facing LIDAR data. I see a lot of folks in here that I instruct a TNGIC-sponsored course, Introduction to LIDAR using ArcGIS. So I see some of you in here. This presentation, you'll see a lot of very familiar information. Basically, I'm going to go through the specifics of the 3DEM program, our partnership, information about the data itself, accuracy information, and then how it's being put to use. And then also talk a little bit about our role and how we're developing some open source training and trying to incorporate that into our workflows and our data sharing. So with that, so obviously it's an exciting time in the Tennessee GIS world. Hopefully you guys have heard about the state's program, and you know, already I've heard some mutterings about it and using our data, as Randy was showing. Currently we've got the Cumberland 27 county project that was flown in 2015. That's available. East Tennessee, that was a 19 county project, and I'll show a map here in just a second. That was flown in 2016, and that's available for download. And then we've got West Middle. We just received the DEMs a week and a half ago, and so we're starting to get that pushed to the TNGIC Google Drive, which I'll go into. So again, I said we had a good partnership with TNGIC. You know, not many folks. I don't know how many folks in here are TNGIC members, but you know, I can absolutely say that it's been an awesome partnership with them and being able to share this data out to the public using a Google Drive account that they pay for. I think it's like $60 a month. We have terabytes and terabytes of data on there. So a good, easy way to share this. So next. Again, I kind of talked about this a little bit, is just kind of the outline and the purpose why I wanted to come and talk to this group, go through our partnership with USGS, our involvement, some deliverables, how to use the data, and then products and common use cases. So if you're not familiar with it, I will go into some kind of cliche. You got like a plane flying over to shoot the lasers down if you're not familiar with what LIDAR data is. But the USGS program, 3DEM program, which is 3D elevation program, is a national program to collect LIDAR data nationwide. And so the state's been participating since 2015. And basically, my director, Dennis Peterson, who's the GIS coordinator for the state, gathers monies basically from TVA, from state agencies. TDOT is a big contributor to get this money together and then partner with USGS to kind of pool our resources so that we can get this great elevation data for our state. So the cool thing about it is that the data is public domain. Now we're using, obviously I work for the state, but this is USGS's data. We just get to help serve it. Here's just a kind of a quick map showing the status. You can see the middle region of Tennessee there. We've already had it flown, and it should be delivered next year in April sometime. West Tennessee is a lot of NRCS data. That's USDA NRCS. That data is out there. It's in UTM meters. But hopefully we'll get some money pulled together and we'll get the western part of Tennessee flown with the 3DEM specific specifications, because it's a little bit older data. All right, so I want to show you, again, intro to LIDAR is kind of the cliche, plane flying over. If you're not familiar with what LIDAR data is, so there's a sensor on, it could be on a plane, could be on anything. You can have it on a tripod, you can have it on a truck. But basically you have a sensor that flies over, and that sensor emits or multiple laser pulses, and you have a GPS on the plane, and so you know that XYZ, and when that laser pulse comes in contact with an object or objects, that gets reflected back to the sensor, and then that XYZ is recorded. So that produces the point cloud that we can then take and get products from and other deliverables. So in specific, the 3.QL2 LIDAR data, you'll hear that quality level mentioned quite often. We've got QL0 all the way to QL3. Our data is QL2, which is an RMSE of 3.9 inches. It's an accuracy measurement between what the actual ground is and the data itself. And then we have a non-vegetated vertical accuracy at 95 percentile, and that's 7.7 inches, which I'll go into on the next slide here. Some specifications, basically, I've got these links active, and when I send them out, if you're interested in any of these links that I have in this PowerPoint, you'll be able to click on them and drive to them. But the base specification is what the contractor, in this case it was Wolpert for USGS, what they had to, what specifications the data had to meet to make delivery. It's basically everything you want to know about the data, accuracy information, all that stuff. So what deliverables did we get in particular? We got the LAS point cloud file, bare earth hydro flattened DEM, and that DEM has a cell size of 2.5 feet by 2.5 feet. If you were working with any of the older USGS data, 30 meter pixel size, this is amazing to work with. It's really cool. But in our DEMs, all the bridges are removed, and that's per USGS specifications. Also, water bodies that are greater than 2 acres and rivers that are greater than 100 feet in width have been flattened. So what that means is that if a pond is over 2 acres, it would have one single elevation value. We also got building footprints. The West Tennessee data does not have, the NRCS data does not have building footprints extracted from that. These are a specific add-on that we have requested because and they're 2D, but they're still a very useful data set that can be extracted from the LIDAR. We also have a tile index and then intensity imagery, and I'll go into kind of some specifics about each one of these. Breaklines, metadata, and then reports and control. So I said QL2 up there. We've got the aggregate nominal point spacing is 2.3 feet. So basically between each point should be 2.3 feet or less. And here's what I was talking about before is we've got the point cloud vertical accuracy. And that's that root mean square error at 3.9 inches. I was kind of getting ahead of myself here. 7.7 in the non-vegetated areas. So USGS breaks it out into non-vegetated and vegetated areas, and because accuracy is affected by vegetation. All right, so the DEM vertical accuracy is very similar, or the same as the point cloud. Obviously, you derive the DEM from the point cloud. So we've got the similar numbers, 3.9 for the RMSE. But you jump up to 11.6 inches when you get into a vegetated area. And that's going to be trees, even low scrub and stuff like that. The more vegetation you have, that can affect accuracy on how that laser goes down through the vegetation, right, to finally hit the ground. So point cloud products and use cases is kind of an introductory slide. I'll go through each one or a few of these just to kind of go through them and tell you a little bit more about them. We've got the LAS point cloud files, and then from that develop digital elevation models. These are provided to us from Wolpert, the contractor, again, hydro flattened with all that processing done. We get intensity imagery, contours, and then we also get those, features, building footprints. You can also extract other items from the point cloud, but ours is only classified to a certain amount, and I'll go into that a little bit. You can also create digital surface models or DSMs. Okay, so how is the point cloud broken out? It's broken out into tiles, and same thing with the elevation models and the intensity imagery. So each tile is 1 square mile. This is just a screenshot of Chattanooga area, and then you can see this an example of the .las files that we received. This may get some booze, right? I don't know. So yeah, STS GIS to save space uses a ZLAS format. There are other open source compressions out there. So at the time that we first started getting our data, and I discussed this at great length with my supervisor, is this the user interface with the Esri product was, even though it's free, it was much better and much easier to compress our files. And also the state of Tennessee is a Esri shop. So
Didn't you guys look? I'm sorry, but
No, go ahead.
did the counties get LAS files? Uncompressed?
Yes, well, some of the, like TDOT or whoever would get, some of the counties, if they pitched in money, would get .las files. But the ones that we have pushed out to the Google Drive, we have compressed using the LAS option.
Yeah, it's not bad.
It's easy. Yeah, it's very easy.
Given that USGS 3DEP has moved to all LAZ for their data, are you contemplating, since you're a partner, to moving to that?
Nope, I can talk to my supervisor about it.
Oh, okay.
More than likely, we'll probably stick with the same ZLAS because we have documentation out there. All the training that I've given is given with this knowledge and using this. So that brings up another point too, is that this data is available not only through our website and the tngis.org site, which is run by Kinjic, is also available through the USGS national map. So on our scale, you can download an entire county's worth of LIDAR data or DEMs, but on the national map, you can actually get singular tiles, which is good because sometimes you may not want to download the entire county. But as you can see, it definitely saved us some space. This is just a 4-tile example going from 1.6 gigs down to 400 megs. Okay, so our point cloud, you can classify a point cloud with up to 255 classes. The USGS specs don't have quite that many, so all of our vegetation is actually unclassified points. So a classification is basically just the ability to identify the feature that pulse came in contact with. So we've got the little profile view, we've got the brown being the ground there on the bottom. My head's not in the way, yeah. We've got red as the building, and then the gray is all unclassified. So vegetation can certainly be reclassified, can be classified after the fact, but for these deliverables, that was not part of it. But we've got unassigned ground, building, water, and then also it says rail up here, but that's basically ignored ground. So if you bring in a point cloud, you might see some ignored ground. But this is from ArcMap too, so it's showing it as rail. Okay. All right. So the products and use cases of the point cloud. I kind of went into some of the specifics. Well, obviously you can create the derivatives that I've listed. DEM, contours, DSM, stuff like that. You can create triangulated irregular networks, or TINs, which is basically you make a triangle between all the points to create a ground surface. That's using the ground classification. You can do elevation and distance measurement, 3D visualization, ground control and georeferencing, vegetation density estimation, and then obviously you do feature extraction, bridges, buildings, stuff like that. Okay, so moving on from the point cloud to the digital elevation models that are provided. Basically a DEM, if you're not familiar, is a raster surface representing that ground terrain, typically bare earth. The cell size is obviously dependent on the LIDAR data. Ours, again, is 2.5 feet by 2.5 feet. On the right there, we've got just a hillshade, and then on the left, just a grayscale elevation of what you would bring in and see. So each 2.5 foot by 2.5 foot pixel has its own elevation value. I discussed the hydro flattening, so there are hydro enforced elevation models out there in the world, but Ours are hydro flattened. So what that means is that the surfaces that meet that criteria, the over 2 acres or greater than 100 feet in width, are flattened. Hydro enforced would be any non-natural obstructions, that would be culverts, things like that, or small ponds that are less than 2 acres, would be taken out to allow for downstream flow. So this is very important when you have to do hydrologic modeling. So I just want to mention it just so in case people are thinking about using these DEMs for hydrologic modeling, you may have to burn in the culvert lines or something like that to basically make your downstream flow happen correctly. Just products and use cases for the DEMs, some of them are kind of obvious. You get a hill shape that I showed before. You can really see that terrain pop. Slope, aspect, shaded relief, and contours. Contours being another one that we generate and share. But landform and landscape analysis in some of these areas in one of my training sections in the Mont Eagle area. And you can see where the rock slides, if you're familiar with that area, I-24 going over the mountain. But you can see rock slides and stuff. It's really amazing. You can also do view shed analysis. This is a view shed analysis on the right here. Basically, you pick a point in space, and you have whatever software you're using spit back the pixels that you can see from that specific point. Again, I mentioned hydraulic analysis. You can do extraction, watershed analysis, and modeling. Planning and construction, this has been one of a very popular, we get lots of data requests. This has been very popular with planning and construction, especially with the ability to generate 2-foot contours. Hazard prediction and then volumetric analysis. The thing about volumetric analysis is this is static data, so if you're in 27 county area, you want to collect the volume or calculate the volume of a rock pile, let's say. That rock pile has probably changed since 2015. But it's still, if you want to see the volume of a mountain or something like that, I'm just saying, it's a static data set, so something to keep in mind.
Quick question.
Yes, sir.
This, of course, I'm looking at this from the 911 community. So what you're saying is I could take that LIDAR data and pull it into my GIS map. I get a 911 call from a guy who broke his leg out deer hunting.
Yep.
I can pull that LIDAR data into on my map where the 911 point is, where he's calling from. I can see that that's a heavily treed, wooded area, and I can tell my rescuers, you're looking for a round tree area or a long tree fence line or whatever.
Sure, you
I pull that data in.
You can, yes, and the way I'm just splitting it, just thinking about how I would view that data. I would probably look at making a DSM that's taking the first return. I think I have an example of it, and I'll show you where you're able to see the vegetation. So there are multiple products that you could use to help identify whether or not that's a highly vegetated area.
Because we've actually had that happen very recently.
Yeah, I wouldn't pull in the point cloud because then you could, but
Right.
it depends on what software you're using and how you're viewing it. So. Certainly can be done. So I just wanted to touch on that hydro flattened again. Just the difference between, we've got culverts and bridges here. The definition is kind of broad. We've had some sections when doing quality control on this data. It's a series of, let's say, box culverts that's 150 feet long. Well, they didn't take that out in the processing because technically it's a culvert, it's not a bridge. So that could really affect some hydrologic modeling. But you can see on the left here, this is a culvert that wasn't taken out. Upstream is to the north. So if you dropped your water droplet or your marble and you rolled it down the watershed, you come in contact with that culvert, and then it'd have to fill up behind that culvert. It's a false dam before it flowed on downstream. But in some cases, they took out the bridges, so you may not have that to deal with. But just again, something to mention.
I've got a question on the bridges. Removing the bridges, how do you get the data from underneath the bridges if you're not? How does LIDAR acquiring that data?
So my understanding of it is just like it is for the buildings. It's taking and this is the elevation model, so it's processing. It has elevation values on either side of the bridge deck, right? It can't get underneath the bridge deck or it can't get underneath the house, right? So The DEM does its best job to just create a surface in between those two elevation values. And that's part of Wolpert's processing when they run the, to generate the DEMs, they're taking these items out and then
Just
creating a
interpolating.
surface. Yes,
Okay.
yeah. And you can see actually on the right, you can see how it's kind of a little bit wonky here. This is just a hillshade, but if you were to pull in the grayscale, you could still see there's a little bit of elevation change. It's not a whole lot, but there's, it almost looks like water because lasers and water don't really get along very well. There's new technologies out there that they're doing bathymetric LIDAR with the green laser. But you can see this is a river that's not wide enough. And on the right-hand side over here, you can't see my mouse, but over here on the right-hand side, you can see it's just trying to do its best job to figure out what the elevation is there. Okay. Breaklines, this is just a data set that they provide us where those areas, the water bodies that are 2 acres or greater, they've been spit out into a shapefile or a geodatabase. And so what that can do is that provides another good hydro data set just to have. So if you're mapping in an area and you need some hydro data, some supplemental hydro data, this is out here. Next thing I wanted to talk about was the intensity imagery. And basically this is kind of a pseudo-ortho that's developed from the reflectance of whatever object or objects the pulse came in contact with. So again, it's a static data set, so if this can be used to fill maybe an ortho hole if you need to know if the building was in there at a certain time. But you can also use it for land use classification, purpose surface delineation, georeferencing, and feature extraction. And actually, we're starting to share more of this on the Google Drive. Before we didn't because the LIDAR and the DEMs were, the point cloud and the DEMs were more, those are higher demand products. But this one is also getting pushed to the drive. All right, contours. So accuracy is obviously dependent on your quality level of your data. So we've got QL2. Aspers came up with and I had to dig to find this. There's no hard and fast. Can I get 1 foot contours from QL2? Well, you certainly can generate them, but it may not be, up to your accuracy standards that you need. But in reading through some LIDAR documentation from ASPERS, which is American Society for Photogrammetry and Remote Sensing, they kind of had this general formula for figuring out your contour interval. What that means for us in our data, in particular QL2, 2 foot contours. So products and use cases, you got cartography-based maps, obviously. Planning and construction has, again, been our largest people touching base with us saying, wanting to use the contours in AutoCAD, let's say, or surveying software. So from that, it's kind of developed, all all these questions being generated. I started doing a lot of research into open source software because a lot of people out there that are using, let's say, AutoCAD, they may not have the money to get an ArcGIS license. So what I'm trying to do is open our data up, and what we're trying to do is open our data up to another user community. And so from that, I've started to develop and have developed a training. I haven't even given my first one, but I've given little bits and pieces at the end of my ArcGIS training. I had some folks in here that just attended my last one. And so people actually were really, really interested in it because they can do a lot of the same things that you can do in ArcMap, but this is free, so it's awesome, it's great. That's why I'm here. So. So what I'm going to do is kind of go through this is very similar to my ArcGIS training, is give a training basically to get the contours out in an AutoCAD or CAD-based software. So going through basically what I just did here is introduce people to the data specifics, the accuracy information. A surveyor, that's going to be their biggest question is, what's the accuracy like on this data? Products and use cases, run through that same thing, run through GIS capabilities, and then teach people how to just add simple data to the map, add our imagery services, for example, and then run through how to use the DEMs, how to create a hillshade, a slope map, and then generate and work with the contours. So we do share contours. We generate contours and share them, but they're large and they're hard to work with. I highly recommend anytime I'm talking with someone, if you don't have the availability and the software extensions in ArcMap, use QGIS because it's robust and you can generate all the contours that you want. And it's a lot easier to work with. You're not working with a county-wide data set. So that's where our role is. I want it to change. The state being an Esri shop. My director and my direct supervisor have noticed this as well, and I've been feeding them information that there's this user group out there and a community out there that can take advantage of this awesome data. We just have to kind of train them, give them a little intro on how to use it, and then they can bring it into their CAD software. So, some kind of concluding thoughts. So data has been shared directly to some 3DEP partners like the TDOTs and TBAs and stuff like that. But everybody else can access through USGS, as I mentioned, the national map, which I don't have added on here. But then you can also access through tnmap.tn.gov. This is our landing page. Oh, what's going on? Did I touch something?
Started bad-mouthing the Esri stuff.
I have Chrome open up. What's going on?
Is it an extended desktop?
I bet you.
It might be. Hang on.
Drag it to the left.
Windows
Sometimes
D.
you need to close the PowerPoint to be able to pull up.
There we go. You're up.
That's duplicated. All right, so yeah, tnmap.tn.gov. This is our landing site. So we have a quick ditty on the elevation project as in specific, and kind of what the projects look like. So we've got the 27 county project. That's the green. Again, that was a 2015 flight. 2016 flight being East Tennessee, and then we've got a 2017 flight. This 12 or 11 or 12 counties, kind of in that Middle West region, and then Middle Tennessee has already been flown. It's in processing now. So we've got some little outliers here. We've got like Van Buren and Sequatchie, Macon, and Blunt. These are all one-off projects. So Blunt, for example, they wanted their LIDAR data now, so they went ahead and flew it, and it's available on our website to download, but it's not necessarily part of the specific 3DEP project, and that's why those are taken out on this project page. But so if you see those gaps, the data is still there, it's just maybe a different project. Let me go back to our GIS data, and that'll be finishing it up for me. I don't know how I'll do it on time. Good. All right, let me go tnmap.tn.gov and GIS data. This is kind of how you access all of our open data that we shared with the public. So we've got an open data portal. That's an Esri product, but you can still download KMLs or shapes of city boundaries, stuff like that. Here are the compressed ZLAS files. So it's broken down per project. So I just clicked USGS 3DEP QL2, and then as you can see, like Scott.
River that you're following with the other data? Or
I'm not sure. I'd have to take a look at specifically on what
did
you're
we
talking
piss y'all
about.
off? Is there something I need to know?
No, so I'm not sure how the project lines were delineated. That may be a question for.
Well, I was actually wondering if it may be the river, if y'all did the river differently. for
Right.
different things.
So that my guess is that it's probably collected in the Middle Tennessee blocks. Whenever that gets delivered, it will cover that. We want to make sure that it's seamless. Yes, sir.
I've actually got about 3 points. First off, your slide says the last return is the ground. That's not accurate.
No. Typically, the last return, right? They generate.
They generate it statistically.
Right, yes.
Okay. Secondarily, the DSM, the first return does not always hit the top of the canopy. A lot of times it goes in, and that'll give you spikes in your data if you're trying to do a canopy layer. And the third thing is with the intensities, is that that's not a, trying to search for the right term, it's not a calibrated metric. It's basically they go out one day, they fly, okay, the high intensity is 255, the low 0. The next day the humidity is different.
Right, and that
And
reflects.
high intensity is 255, the low 0.
Right.
And so you can't really do a true radiometric analysis of the data.
So makes land use classification a heck of a lot harder.
Right. But it is quite useful in a visual.
Yes, yeah, that's why I like to term it as that pseudo ortho, because it kind of creates an extra image. I wish we had ortho flights actually flown when we had this LIDAR flown, but it's typically flown at night. Any other questions? Comments? Yes, sir.
So what time of the year are these flights being done?
They're done in the winter, so leaf off. So typically you want, as little amount of vegetation as possible, and that way you have a better chance of hitting that ground. It makes a big difference. Yes, sir.
Hi, did you say that you had constructed a building footprint?
Yes, so those are available per project. So that 27 county project, there is it's either a geodatabase or a shapefile that you can download and bring in that file, and it's got building footprints. They had to hit, I think it's like a 98 or 95%. There are some buildings missing. We provided these buildings to the folks that were responding to the wildfires in Sevier County, and they found quite a few buildings. That was pre-QC data, but it was super helpful, but they did notice that there are some buildings missing, especially in high vegetation areas. It's automatically done, so it's just, yes, sir.
Do those footprints include the attribute data, like the height of the building?
No, they don't. So these are all 2D polys that don't have any associated attribution with them. You certainly could generate, going through some processing to get the Z values. Yes, sir.
Have you compared those polygons to the ones that Microsoft just released?
No, I'm not. I didn't know Microsoft released any.
Two-part question, if I may. One, do you have any projected timeframes when you may be offering the QGIS training class you were talking about?
Sure. Yeah, I was just talking with Kinley on our staff. My supervisor just gave me access to WebEx, so I'm going to start looking at doing webinar formats for both Esri and the QGIS. But if there's a need, I've talked to you, may come down to Chattanooga and give that. Currently, I get to work on the QGIS stuff in my kind of downtime or my off time. So I generated the content in 2.18, I think, and now I should probably get that updated to 3.0. But it's usable, and I'd be happy to send that out to anybody if you want to contact me. It's ready to go. So.
The second part question, I know it sounds like I'm sounding ungrateful with this, but I think my head in shame. Do you have any plans of reflying the state in the future? Like, will it be flown every 10 years, every 20 years, or no, this is a one-time shot at doing this?
Sure. That all depends on funding and how much this data is being used. So I'm gathering all the time from my courses and trainings and talking with you folks here. I'm always mentally logging, and I actually have a list of things that people are using this data for. Because the more that people use it and the more value they see in it, the more that my director can go to the TVA and TDOT and say, hey, it'd be awesome if we could get another flight of this, especially if we can get that USGS funding. So if they go through a cycle, I would certainly say that the state would pursue that. So, but no plans at the time. Yes, sir.
So is anybody doing vegetation analysis with these data?
So I've contacted the state, one of the state foresters. He's done vegetation analysis with it. One in particular was he did the post-wildfire analysis using how much vegetation was covering up the roofs, because there was so much. There's a large difference in did that house catch because it had vegetation overhanging it. So I think he actually is going to publish a paper here coming out pretty soon. So Yes, sir. It is being done. Yes, sir.
You know if FEMA's gonna update the flood maps with your data?
Good question. I sure hope so. That's part of the driver here too. It's certainly in the works. I haven't had any direct contacts with FEMA.
The one-off counties that you mentioned, did they also get the building footprints? Do you know?
I think Blunt did, but I don't think Van Buren, Sequatchie, and Scott did. But Esri Booth, right, they have a classified as building tool, and I'm not sure if like Saga or Grass has a classified building tool, but I'm sure that there's one out there. It's got to be. Yep.
Yeah, they do.
Yeah. All right. Excellent. So you can go both ways. All right. Awesome. Yeah. Let me know if you got any questions. I'd be happy to follow up. And my phone's always, I'm always happy to take questions.
Yeah, because, I mean, I've thought about doing like an open source LIDAR something here in the state, so maybe we could figure out some way to,
Absolutely.
cross funding streams.
Yeah, that would be great. I'm always looking, like, if you're already using our LiDAR data, I'd love to talk with you because, again, I'm always logging, like, how our data is getting used and